What are you doing?
I'm listening to the radio.
Remember when we did the time slip and pretended we discovered radio waves from space?
Yeah, that was fun. I won a Pulitzer Prize for my article on that, you know.
What? You didn't win any Pulitzer Prize. We were just pretending, and you did not even write a real article. Besides, no one would vote for you to win a Pulitzer Prize anyway.
Leica voted for me.
You two are just plain silly. There's still a lot to tell everyone about the world of radio astronomy, so how about if we do this month's Rigel Astronomy episode about the nuts and bolts of radio astronomy? Let's Explore Astronomy is sponsored in part by
Distinctly Yukon. The Westmark Whitehorse Hotel and Conference Center is the Yukon's premier lodging facility. Make your reservations today at westmarkhotels.com. Westmark Hotels, with 9 unique locations throughout Alaska and the Yukon.
This is 93.5 FM, playing your favorite music for the entire metropolitan area. We are all familiar with the radio. We know there are tons of stations on the radio dial at both the AM band and the FM band. Each frequency is made of a specific length radio wave. At the station, the music is encoded or modulated onto a carrier wave, which is the frequency the radio station transmits on, 93.5 for example. When you dial a certain station's frequency in, the radio tunes to that specific wavelength and demodulates or decodes the music signal, then amplifies it and sends it out to the speakers to your ears in the form of vibrations or sound.
But it is very important to know that sound and radio waves are two different things.
Radio waves are like visible waves and part of the electromagnetic spectrum. They are actually the longest waves in the spectrum.
Wavelengths are measured from the tops of each wave.
Sound, on the other hand, is pressure variations moving through a medium, such as air or water or gases. Radio waves are energy and can travel through almost anything, including a building or even the vacuum of space.
So use a cell phone, for example. When you talk into your phone, your mouth creates sound which goes into the phone. Hey, Hark! The phone encodes that sound by turning it into an electric signal that is encoded into an electromagnetic wave.
That wave can travel out through walls and such and eventually get beamed to the person's phone you are calling. That phone receives the electromagnetic wave, extracts the electric signal, and converts it back into sound that then goes out of the phone and can be heard.
Hey, Hark! So a sound wave cannot travel through the vacuum of space, but electromagnetic radio waves can. Get it?
Radio waves travel across distances just like light waves do at the speed of light. But sound waves travel at a slower speed. Do you know how fast sound waves travel?
Mach 1.
Correct. We call it Mach 1 for short, and it equates to about 760 miles per hour.
And Mach 2 is twice the speed of sound. Mach 3 is 3 times, and so on.
But the speed of sound varies depending on the temperature and atmosphere. So that number applies only to a standard day at sea level at 15 degrees Celsius, 59 Fahrenheit. As a sound wave moves through different densities and temperatures of air, the speed changes. Same with water and gases like helium. Mars has a different atmosphere than Earth, so the speed of sound is different than on Earth. On Mars, the speed of sound is only 545 miles per hour.
A great way to see and hear that sound moves slower than light is when there's a lightning storm. You'll see the lightning first, then hear it later, because the sound moved to you slower than the light.
1, 2, 3, 4, 5... It took about 5 seconds for us to hear the thunder after we saw the lightning, and since sound travels about 1 mile every 5 seconds, that lightning strike was about a mile away.
What you don't want is to see lightning and hear it at the exact same time.
Yikes!
like that. Hey, where did Herc go? Oh my, I hope he did not get zapped by lightning and disintegrate. Herc, where are you? You better get inside get out of the storm.
I'm not an idiot. I wasn't going to stand outside in a lightning storm and get electrocuted. As you can see, no storm here today. I am at Arecibo in Puerto Rico. As you recall from last month's Rigel episode, we showed you various designs of radio telescopes. This is called a single dish antenna scope because it is only one very large telescope. It searches the sky for radio signals from outer space. A radio telescope works much like a reflector optical telescope, like you might have in your backyard. But instead of gathering light, it gathers radio. The radio waves come in and bounce off the curved dish and are focused on the receiver hanging above it. Here you can see the receiver for the Arecibo scope. It is not small, it sits 500 feet above the dish. The radio wavelengths are much longer wavelengths than visible wavelengths. Thus, the dishes must be bigger. So what is it hearing? Well, like you just learned, it is actually not hearing anything. Not sound, anyway. It is receiving the radio waves of the electromagnetic spectrum. I should actually first send Velocity an electromagnetic radio wave. I will text her to tell her I'm okay. I will type letters into the phone, and the software will encode that onto a radio wave that will then be sent out around the world, eventually getting to Velocity's phone at the speed of light, where it will be decoded and she can read it.
I just got a text from Herc. He's in Puerto Rico. Don't get a tan without me. When we visited with Carl Jansky, he picked up a radio wave from outer space. What he was doing was the same as your radio or cell phone does, taking the radio wave and converting it into sound. He got a hiss. Tune your radio to a frequency between stations and you will hear the same thing. You're right, Leica. That's nothing but static. And it doesn't mean anything to radio astronomers either. What astronomers do is plot the strength of the radio waves with color. Here's the Milky Way in radio waves. The red is the strongest signal, the yellow weaker, and the blue even weaker. You can see the strongest radio waves are from the center of the Milky Way, and a lot weaker at the edges of the galaxy. So what produces radio waves? Energy, radiation. Strong radio waves are emitted from supernovas and black holes, as well as pulsars and quasars. We'll explore what we are learning from radio astronomy when we explore those objects on future episodes, so stay tuned. But one fantastic discovery was just made at Arecibo, and since Herc is there right now, we should let him tell us about it. Herc, come in, Herc.
Recently, this telescope at Arecibo was observing a distant galaxy 44 million light-years away called NGC 660 in the constellation Pisces. The study was looking at molecules in the galaxy over several years. NGC 660 had always been a relatively quiet galaxy, until one day the telescope picked up a huge burst of energy from the center of NGC 660. A burst that was 10 times brighter than the largest supernova ever recorded. It was incredible, but what caused it? Radio telescopes around the world were aimed at NGC 660, and the information gathered by all of them was put together to solve the mystery. Scientists thought they would see a massive supernova, but instead saw 5 bright radio transmission sites, 1 at the center of the galaxy and 4 around it, 2 on either side. It is probably the jets of particles being blasted off as material is being sucked into a supermassive black hole. It'll take a few more years of observing and study to confirm this, But what a cool discovery.
Wow! That is so cool! We are discovering more and more every day. And we have radio telescopes around the world and in orbit. And of course, we have radio telescopes looking for that transmission that is not just white noise energy, but a message from another world. The project is called SETI, the Search for Extraterrestrial Intelligence. If aliens on another world had radios and TVs like us, then we might just pick up their signals and think our radio waves just have traveled into space, and there might be an alien radio astronomer right now on another planet about 50 light years away listening and trying to figure out our radio broadcasts from the last century. Until next time, happy stargazing!
Hey, give a shout out to our sponsors, without whom we would not be here. Visit their websites and partake of their services and products. A big thank you to the Yukon Department of Tourism and Culture and Westmark Hotels, Westmark Whitehorse.